In this session, we are going to learn about dielectrics. Dielectrics are insulators which when placed in an electric field produce charges on their faces. So they are classified into two, that is polar dielectrics and non-polar dielectrics. So let's look at the first one, that is polar dielectrics. They are formed by the polar molecule, for example H2O, HCl, etc. Positive center of the molecule negative center of the molecule coincide ചെയ്യുന്നില്ലെങ്കിൽ അതിനെയാണ് polar molecule എന്ന് പറയുന്നത്. So here each molecule will have its own dipole moment. Now if you are placing this in an electric field, all molecules will align in a particular direction, and as a result one phase of the dielectric will become positive and the other phase will become negative, and as a result a dipole moment will be induced. So in case of polar molecule, a dipole moment is induced in the presence of an electric field. The next one is about non-polar dielectrics. They are formed by the non-polar molecule, for example N2, O2, benzene, etc. Positive center of the molecule negative center of the molecule coincide ചെയ്യുന്നുണ്ടെങ്കിൽ അതിനെയാണ് non-polar dielectrics എന്ന് പറയുന്നത്. So we can say that it does not have its own dipole moment. Now if we are placing this non-polar dielectric in an external electric field, the positive center of the molecule will move in the direction of electric field and the negative center will move in the opposite direction of that of electric field, and as a result positive and negative charges will be induced on its opposite phases. Thus we can say that there is a net dipole moment. So this process is called dielectric polarization, and the dipole moment induced is called as the induced dipole moment. So if we are placing a polar or a non-polar dielectric in an external field, there will be a net dipole moment. Next we are going to learn a new term, that is polarization. Induced dipole moment per unit volume is called as polarization, and it is denoted by the letter P. For example, in case of a linear isotropic dielectric, the polarization P is given by the equation P is equal to chi E into E, where chi E represents the susceptibility. Next is about dielectric constant. It is the ratio of normal electric field to the reduced value of electric field due to polarization. Normally, the dielectric constant is represented by the letter K. So if E0 represents the normal electric field and EP the electric field due to polarization, we can express the dielectric constant as E0 by E0 minus P, where E0 minus EP the reduced electric field due to polarization. Next is about dielectric strength. The maximum electric field that a dielectric medium can withstand without the breakdown of its insulating property is called as the dielectric strength. In case of air, it is 3 into 10 raised to 6 volt per meter. So these are some of the terms coming under dielectrics, and I hope you have understood this.
Hi everyone, I'm your educator. In order to watch high quality content videos, please download Stuid Learning app. Happy learning guys.